Right, so now that you basically have an idea of what oblique projection is, you can see that I have a simple object here, and this is an isometric projection, right? So before we start constructing this in oblique projection, what we're going to do, we're going to create a few layers, right? So our first layer, we can call that receding line, and we could change the color to a different color. And for the next layer, we could call it front view, seeing that you would have to construct the front view first. And we could create the last one, which is going to be the outline, right? Just like you had done with the isometric projection, right? Please remember that whenever you're doing an outline layer, you need to use a thicker line weight, right? Since that's going to be like the final product. Right. So now what we could do, right? Remember the first step to this would actually be drawing the front view of this object, right? So in this case here, our front view that we're going to use here is going to be this L shape that you see on the right receding axis here, right? So we can see that it has a length of 100 and then it goes up to 50 mm. And we can see that this line here in the middle goes up to 25, right? And then the line here is 50. So we can start by drawing our baseline. But before we start drawing our baseline, please ensure that you have ortho mode on. So we know that the baseline is 100 mm, right? You can see that I have my 100 mm line there. And we know that on the right hand side of this line, it has to go up 50, right? So on this side, it's going up 50 mm. And I don't think I need to remind you that you need to set your units, right? That is something that we've been doing basically every class when you use AutoCAD, right? So you're going to notice that things that we've learned before, I'm not going to go over them back. And if I were to do that, then it's basically going to make the video very long, right? Which I'm sure you don't want. So for the line on the left hand side is going to be 25. So going up here, 25. And we know that the length coming back here is 50, right? You can see that from the image here, right? And then it goes up here and it comes back here, right? So we know that this is basically half and half, so it's going to go up 25 and it's going to come back to end off the shape there, right? So from here you go up 25 and you end off the shape here. Now this is what your front view looks like, right? It's basically an L shape, right? And remember, since this is oblique projection, the front view will always be drawn to the full measurement or the full scale, right? Now, for this example here, I'm going to draw this in cabinet oblique projection. And if you can remember from the introduction video, we know that the receding lines, we're going to draw them at half scale. So everything here is 50, right? Which means that we're going to use half scale here. So instead of using 50, we'll be using 25, right? So always remember, whether it be cabinet oblique projection or cavalier oblique projection, the front view of the object is always drawn to its full size or full scale, The only thing that would determine the size of the receding line would be if it's cabinet projection or K-Valea projection. And seeing that it's cabinet, we're using half scale, right? If it was K-Valea, we would have used full scale, and that means that you would have used the full 50 here, right? But for this example, I'm using cabinet, so we gotta go half of 50, which is 25. So we can switch to this layer, which is called the receding line, and I'm just going to turn ortho mode off, right? So for each vertex, that's each point here on this shape, we need to have lines that are of two things, right? The line has to be at a 45-degree angle, and the length of the line needs to be 25 mm. So I'm going to start with this point here first. Click on this point, and you're going to notice that I have to draw this at a 45-degree angle, right? Now, usually on the right hand side here, 45 would be there, right? As you can see. But in this case, in order to know what would be the 45 degree on the left hand side, you need to minus 45 from 180, which is going to be 135, right? So in AutoCAD, it's kind of different from when you're using your protractor, right? Remember, the protractor would show both angles, whether you use the left hand side or the right hand side. But in this case, right, if you need to know the angle for the left hand side, right, seeing that it's 45, you minus it from 180, right? So you're going to press your tab key here, and you're going to type in 135, since that's the angle that we gotta use, right? Then you're going to press your tab key again to switch back to the length, and you're going to type in the length, which is going to be 25. When you have those two values entered, you just press the enter key, and you press the escape key to stop drawing. So this is your 45-degree line, right? Instead of doing that for each point now, basically, we can copy and paste it. So you click on your line to select it, you click on your copy tool, and from this point, you copy it to the remaining vertices here, right? So I think that's pretty much all of the points that we have covered there. And now we could actually start outlining. So looking at this shape here, we know it's a L-shaped block. And simply put, we just gotta connect here, 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 and I'm not going to connect here because the front view would be blocking this part here. So I'm going to delete this line. Alright? And I'm just going to turn on the line weight. We looked at this the last class, so I shouldn't go over that back. And I'm just going to outline the rest of your drawing so that it would look more presentable this way. And that's basically it for the oblique projection here, right? So you can see how different it looks. Let me just make this image smaller so you could see it better. And I'm just going to move this closer to the image. So you can see how different the oblique projection actually looks from the isometric projection, right? Um, Sometimes depending on how you view it, the isometric projection might show more details compared to the oblique projection, or sometimes the oblique projection might show more details compared to the isometric projection. But the point is that both of them represent a three-dimensional object. It's just that the angle that you view the object from looks different, right? So although I sent a video on this, I wanted to go through the dimensioning now for this object here, right? So you want to make sure that you switch back to your default layer here, right? But before we can start dimensioning this drawing here, we need to change a few settings. And please remember that this is something that you need to do every time you do a new drawing, just like how you set your units at the beginning, right? So at the top here on the Home tab, you're going to see this bar called Annotation. You're going to click on the arrow, and you're going to choose the second icon here, and you can see that they call it Dimension Style. So this dimension style is incorrect. This isn't the standard that the Caribbean uses, right? So you want to click on Modify, and we're going to start from the Force tab here first, right? Which is called Lines. So all of these here are basically going to remain the same, excepting for this option that says Extend Beyond Dimension Lines, right? We want to change that value to 3. So moving over to the next tab, which is Symbols and Arrows, you want to make sure that all of your symbols here are closed arrows, right? Your arrow size is going to be 3. And then we can move to the next part, which is text. For text height, you want to change that to 5. And for text alignment, it's on horizontal. We want to change that to ISO standard, right? There's this other option here called offset from dimension line. You want to change that to 2. And for text placement here, for vertical, you want to change it to above the line. For fit, everything is going to remain the same. And for primary units, you're going to change the precision here to 0, right? Because we don't want any decimal numbers. Everything else is basically going to remain the same. So once you have all of that set, you just click on OK. And now we can start dimensioning. So on the same annotation tab here, right? You can see that there is this part called linear, and if you click on the arrow next to it, there are different types of dimensioning that you can use. But for now, we're going to use the linear dimension here, right? So we can dimension this side here, and you can see that it's telling me it's 100, which is the correct measurement. We could dimension this side here, and that one's going to be 50, right? Now, for the other dimensions, where you have these slant lines, or the lines that are at an angle, you want to use the type of dimension that is called aligned, right? And it's very important that you remember these things, because I don't want to have to keep going over them every lesson, right? So we use them for lines that are at an angle, like this one, right? Similarly, you could also use it for any other line that's at an angle, like this one. But seeing that these two measurements are the same, we could simply delete one, right? We don't want a repeated dimension. And that's basically it for dimensioning, right? So in the next class, what we're going to do we're going to look at the next assessment or the force assessment, which is going to be based on something we did last term, reduction and enlargement. And maybe if you have time after completing this oblique projection, you could look at the video one time.